Hello, good afternoon, Dan. Uh, to begin with, I set up three type of moves. I set up three type of moves that the laser can have from when it exits the emitter until it enters the detector. So the first one adds 1 to X to represent straight movement, which is toward the east direction. And the second one adds 1 to Y 1 to Y to represent up moments, and similarly the third one will subtract 1 from Y to represent the downward movement. In a similar way, I set up diverting the direction of the laser from one point to the other point. So we have four possibilities for diverting the lasers, and we are using two types of mirror setup, which are the front slash and the back slash. So we need a starting point which is X and Y. Using the front slash, we can divert the mirror to upward direction to get to the another mirror. The coordinate of X and Y increases the increases and also decrease the value according to their movement direction. So if it is going upward, it will increase the movement, and if it's going downward, it will decrease this. So here I set up a next move function here, which take my laser from one point to another point. So these are all the we need the position, the starting position, and the mirrors, and this mirror will change the direction of the lasers and take it to the new position, which is also a new mirror. And for the safe move rules, it takes a list of coordinates which represent the position of the person, as that's the whole. This all the coordinates in here is the whole rectangle, and it give us the true value. It will give us the true value. If it is not, so this slash plus is the negation in the prologue that it took me some time to figure out. So, and it will give us the true value if laser is not going through the position of the man. So this is the pretty much same thing we did in our micro lab. The rectangle function checks the coordinate if they are inside the grid, which I have done in our micro lab, with simply doing some math and checking the bounds of the rectangle if these two X and Y points are inside this rectangle. In the same way, let's look at some of this recursive function. For the recursive function here, we are checking if the position is in the path. If the position of the obstacle, or if the position of the man is in the path of the laser. So just want to we also have to look for the safe movements. So the safe move, as I say that the safe move rules takes the coordinate which represent the position of the person, and it will give us true value if the laser is not going through. In here we also have another recursive function which is checking if recursive function which have the initial state, which is the starting states, and we have the final states with the main position, obstacles, and the way that the laser is going through, mirrors, and the final mirror will be the ending mirrors. What is happening in here is we are looking to see if uh, the main position is safe or not, and the number of mirrors are always less than or equal to 8 in any cases. And also it will check and return the true value if the new position is not in the way. So at the last, I did the add last function. It will add the list of valid mirrors whatever we get at the end of the list, and it will just give us all the list of the outputs. So let me just run this real quick and show one of the example that this is working properly. So let me consult this one. Okay, so and here is the example from the project. Oops, let me do that again. So here are all the possibilities that we have, and let me tell you what's happening here. So the first one I get 1 2 3 4 5 6. So these 6 are, so the first answer is using 6 meters to get the laser from uh, the starting point to the ending point other side of the wall. So this one used the 6 meter. In a similar way, the second one is 8 meter. Let me do a couple of more. Alright, so let me do this one. This is the pretty much same output that you have in the uh, assignment. So this one use 1 2 3 4 meters. uh, and what I know from here is the x here, that x is storing all the values, all the valid path of the laser, and it will keep going on and on. Alright, thank you.